A warm welcome to all of you. Today we will see the essential features of machine learning. The first one is automation. Let us start with the most important feature, automation. Machine learning enables a system to perform tasks automatically without explicit programming. Once trained, the model can make decisions on its own. Example, automatic email spam filtering, automated recommendation systems. Let us start with the most important feature, automation. Automation means performing tasks automatically without continuous human involvement. In traditional programming, if we want a system to work, we must clearly define every rule. If this happens, do that. If that happens, do this. This becomes very difficult when conditions change frequently. Machine learning remove this limitation. Once we train a model using past data, the system learns decision making logic by itself. After deployment, it performs tasks automatically even when new situations arise. For example, in email spam filtering, no engineer manually checks emails. This machine learning model automatically classifies emails based on learned patterns. This saves time, reduces errors, and allows the system to work 24/7 without human fatigue. So, the next one is learning from data. Machine learning systems learn patterns directly from data instead of fixed rules. More data generally improves model accuracy. For example, learning customer behavior from purchase history, learning speech patterns from audio data. So, machine learning systems learn from data, not from hard coded rules or something like that. This is the fundamental difference between machine learning and traditional software. Data can be structured or unstructured, numbers, text, images, audio, or videos. The machine learning model observes this data, identifies patterns, and builds internal logic. For example, customer purchase history contains information about preferences, budget, frequency, and trends. Machine learning models analyze this data and learn customer behavior. In speech recognition systems, thousands of voice samples teach the system pronunciation, tone, and accent. So, here data itself becomes the teacher, not the programmer. So, next one is self improvement. Machine learning models improve performance as they are exposed to more data. This makes systems smarter over time. Example, YouTube recommendations improving their usage, search engines refining results. So, one powerful characteristic of machine learning is self improvement over time. In normal software, performance remains constant unless we manually update it. But machine learning systems continuously improve as they receive more data. Initially, predictions may not be perfect, but as users interact with the system more and more, the model learns from feedback and corrects itself. For example, YouTube recommendations improve based on watch history. Search engine improve results based on user clicks. This ability to learn from experience makes machine learning systems closer to human intelligence. So the next one, if we can able to see the pattern recognition, machine learning can identify hidden patterns in large data sets. These patterns are often difficult for humans to detect. Examples, fraud detection in banking transactions, disease pattern detection in healthcare. Machine learning excels at pattern recognition, especially in large data sets. Humans struggled to analyze millions of records, but machine learning algorithms are designed for this purpose. In banking, machine learning detects fraud by recognizing abnormal transaction patterns. In healthcare, disease patterns are identified from medical reports and scans. These patterns may not be obvious to humans, but machine learning systems detect them efficiently, enabling early detection and prevention action. So the next one is scalability. Machine learning systems can handle large volumes of data efficiently. They scale well with the increasing data size. Examples: social media data analysis, e commerce product recommendations. Scalability refers to a system's ability to handle growing amount of data without performance degradation. Modern applications generate massive data daily. Traditional systems cannot process this efficiently. Machine learning systems scale horizontally using distributed computing. For example, social media platforms analyze billions of interactions daily. E-commerce platforms recommend products to millions of users simultaneously. This scalability makes machine learning suitable for real-world big data applications. So the next one is accuracy improvement. Machine learning models provide high accuracy when trained properly. Accuracy improves with better features and data quality. Examples: weather prediction models, face recognition systems. Accuracy measures how correctly a system performs predictions. Machine learning models improve accuracy through training, feature engineering, and data quality improvement. For example, weather prediction models use historical climate data to forecast accurately. Face recognition systems identify individuals with high precision due to large training datasets. Thus, better data leads to better accuracy, which leads to reliable decision making. The next one is adaptability. Machine learning learns models adapt to new data and changing environments. They do not require frequent reprogramming. Examples: stock market trend analysis, dynamic pricing systems. Adaptability means the ability to adjust to changing data patterns. Real world environments are dynamic, not static. Machine learning systems adapt automatically. For example, stock market trends change every day. Machine learning models adapt without rewriting code. Dynamic pricing system adjust prices based on demand and competition. This adaptability makes machine learning systems future proof. The next one is data driven decision making. Machine learning systems make decisions based on data analysis instead of assumptions. This reduces human bias. Examples: loan approval systems, business forecasting tools. Machine learning enables data driven decision making instead of assumptions or intuitions. Human decisions are often biased, maybe often biased. Machine learning decisions are objective. Loan approval system analyze applicant data, not emotions. Business forecasting tools predict growth using historical trends. This improves fairness, accuracy, and consistency in decision making. So the next one is handling complex problems. Machine learning can solve complex and non-linear problems. Traditional programming struggles with such s- tasks. Examples: image recognition, natural language translations. So the next one is predictive capability. Machine learning models can predict future outcomes based on historical data. This helps in planning and risk management. Examples: sales forecasting, student performance prediction. Prediction is a core strength of machine learning. Using historical data, machine learning models forecast future outcomes. Companies predict sales to manage inventory. Universities predict student performance to identify weak students early. Predictions helps in planning risk management and strategic decisions. So the next one is real-time processing. Machine learning systems can analyze data in real time. This is crucial for time sensitive applications. Examples: online fraud detection, traffic monitoring systems. Some applications require immediate response. Machine learning systems processes data in real time. Fraud detections, blocks, translations are the major aspects of this real time processing. The next one is feature extraction. Machine learning automatically extract important features from raw data. This reduces manual effort. Example: image edge detection, text keyword extractions. Feature extraction means identifying important information from raw data. Machine learning automates this process, reducing human effort. In images, edges and textures are extracted automatically. In text, keywords and sentiments are detected. This improves performance and reduces complexity. So, the next one is generalization. Machine learning models generalize learned knowledge to unseen data. This ensures good performance beyond training data. Examples: new user recommendations, predicting unseen exam questions. So, generalization is the ability to perform well on new and unseen data. A good machine learning model does not memorize, it understands patterns. For example, recommending products to new users, predicting exam questions not seen during training. Generalization is the true test of machine learning intelligence. So, the next one is reduced human intervention. Once deployed, machine learning systems required minimal human involvement. They operate continuously and efficiently. Examples: chatbots, automated quality inspections. After deployment, machine learning systems need minimal supervision. They operate continuously without manual involvement. Chatbot handles customer queries. Automated inspection system detect defects. This improve efficiency and reliability. The next one is multidisciplinary usage. Machine learning is used across various industries. It is not limited to a single domain. Example: healthcare, diagnostics, financial markets. There are so many other applications where machine learning frequently used. So the next one is handling noisy data. Machine learning algorithms can work efficiently even with noisy or incomplete data. They identify useful signals from noise. Examples: speech recognition in noisy environments, sensor data analysis. Real world data is noisy and incomplete. Machine learning extracts useful information from such data. Speech recognition works in noisy environment. Sensor data analysis filters errors. This makes machine learning practical and robust. And the next one is cost efficiency. Automation through machine learning reduces operational costs over time. It minimizes manual labor and errors. In the overall, the cost also will be decreased. The examples: automated customer support, predictive maintenances are the examples where we can able to minimize the cost. The next one is continuous learning. Machine learning systems can continuously update models with new data. This keeps systems relevant and accurate. Examples: news recommendation engines, personalized learning platforms. Machine learning systems continuously learn from new data. This keeps them relevant and accurate. News recommendations adapt to preferences, learning platforms, personalized content. Continuous learning ensures long term performance. The next one is personalization. Machine learning provides personalized experiences based on user behavior. It enhances users' satisfaction. Examples: Netflix movie recommendations, online shopping suggestions. Personalization enhances user experience. It is well known to us. Machine learning systems tailor content to individuals. Netflix recommendation movies, we can see nowadays. Online stores suggest products. This increases engagement and satisfaction level of the people. And the last one is high speed processing. Machine learning processes large data sets faster than humans. This enables quick decision making. Examples: high frequency trading, real time image classification. Machine learning processes data at very high speed, decisions made in milliseconds. Uh, High frequency trading operates instantly, real time image classification is possible. Speed gives competitive advantage. These are the various types of features of machine learning we can see.